This next video is now taking the chi-squared value and setting up all steps. What we're trying to prove is there a connection between the variables. You start off by supposing there's no connection, which is what we call the null hypothesis. We're going to find the probability that the connection will occur, and we're going to find it within 5% significance level if there's a connection between the variables. Theoretical distribution. These are just some graphs for you. You don't need to really know much about it. There's what we call a degree of freedom. And think about your bell curves of data, and your teacher might grade you on a bell curve. This would be not a very pretty bell curve, this first one, right? We want them to be like this, a nice bell curve. And depending on the degree of freedom is how much that curve changes. So here's some just different examples of some degrees of freedom of 1, 4, and 20. We're going to calculate the degree of freedom in just a little bit. How you calculate the degree of freedom is this equation right here. We take the number of rows, the total rows, minus 1 times the total number of columns in your data, minus 1, and then you just multiply them together to figure out your degree of freedom. Then this chart we have to use. Someone already has calculated it all out. So let's say, for example, we did our degree of freedom at 4. Then it says 10%, 5%, 1%. We want this number here, 9.49, to use later. So from the chart, we can see that at 5% of 11.07 has a 5 degrees of freedom. So what we're going to do is we're going to see if it comes in or it doesn't go in. All right. What we want to find out is in this curve, the area of rejection. Is it greater than or less than this chi-squared value? So here's your chi-squared right here. If it's less than, or is it greater than that value? And here's what chi-squared value, which we already figured out in the last video. If chi-squared value is greater than the critical value, we reject the null hypothesis and accept the alternative. If the chi-squared value is less than the critical value, then we accept the null hypothesis and reject it. So it'll make more sense when we get into the steps. Okay. So here are all the steps. Don't write them down. You can pause it if you want to, but we're going to go through these 7 entire steps to test if they're independent or dependent. So here's an example. These are our observed values. Column 1 represents who has regular exercise, 110 males, 98 females. And then in column 2 are the people that don't have regular exercise, and the total sample space is 400 people we want out and collect it. Remember, these columns and rows become important when we calculate the expected values, what it should be. So the question, are the variables for gender, males and females, and people who regular exercise and don't, is there a connection between them? Are they independent or dependent of each other? The variables may be dependent on each other. For example, females may be more likely than males. That kind of explains what we're going to check for. So here are all the steps, the 7 steps broken down for this problem. State the null hypothesis, HO, is that gender and regular exercise are independent of each other. Independent. Then the alternative is H sub 1 is that regular exercise and gender are not independent of each other. They depend on each other to get that data. Okay? So not independent, H sub 1. So there's step 1. Step 2 is to calculate the degrees of freedom. So you take the number of rows and the number of columns. In this case, there's 2 rows and 2 columns. Just ends up becoming nice. It doesn't always have to be 2 and 2. You could spread out your data. So you substitute 2 rows, 2 columns, simplify it, and your degree of freedom is 1. The next step is to quote the significance level. We're going to use this box right here. Significance level will always just be 5. We kind of go on a 5%. So you say significance level is 5%. Now step 4 says state the rejection inequality. So chi-squared calculation, which we haven't calculated, is going to be greater than k, and this is our k value. We have a degree of freedom of 1. This is 5%. So the number we're going to work with is 3.84. We want to see, does our chi-squared value, is it greater than or less than 3.84? So there's step 4 out of 7. Now we're going to go ahead and calculate the expected values. So we're going to work with these 4 numbers. So we'll start with 110. We take that to figure out, this is the observed, we want the expected. We're going to take the row and the column total and multiply them. So 216 times 208, and then what are we going to divide it by? Your entire sample space of 400. So 216 times 208 divided by 400, you're expected to get a value of 112.32. We got a value of 110 in our data. So we're going to use this later. Okay. Now we'll go to the next box. This is the observed. We want to figure out the expected. So we're going to do the same row total and now the column total. So 216 times 192 divided by 400. 216 times 192 divided by 400. The expected value is 103.68. We got 106. It's pretty close. All right, we have 2 more boxes to fill in to find the. So now we're going on to the females. We want to figure out what is the expected here in that box. So we take the row total and the column total, so 184 times 208. 184 times 208 divided by 400. And it's 95.68. This was 98, so we're pretty close. All right, last one. We want to find out the expected in this box. So the observed was 86. We take the row total and the column total and multiply them together. So 184 times 92. 192. And divide by 400. And we get 88.32. We don't care about these boxes. We just want these 4 circled numbers. These are what we call our expected values. Here it is in a prettier form, a little nicer with it all typed up. And that's just explaining how to do the rows and columns and dividing. All right, so what I have now is we're going to calculate chi-squared. This is called the contingency table. It's taking this formula. What this says is take the sum, sigma, take the observed minus expected, square it, and divide it by the expected. We just have it in a nice, pretty organized chart instead. So now we take 110 minus 112.32, and we get negative 0.232, and then we're going to square that number. 5.38, and then we're going to divide it by E. So 5.38 divided by your expected and you get a pretty small number, 0.047. Then you do it for the next row, 106 minus 103.68, 2.32, square it, 5.38. Take 5.38 and divide it by the expected. And you get 0.051. Then take 98 minus 95.68, square it. So 2.32 again, 5.38, 5.38 divided by 95.68. And we get 0.056. Last one. 86 minus 88.32, negative 2.32, square it, 5.38. Just happens to be they're all the same number. This will not usually happen. And then divide it by the expected. So 5.38 divided by 88.32. And we get 0.069. And now what we do is we total up these four numbers. 1, 2, 3, 4. That's the sum. 0.2170. This is the chi-squared value. Now what does it mean in our problem is going on to the next step. Step 6. Either accept or reject the null hypothesis based on the result of the inequality. So remember, this is from that big box. Let's see if it's true or not. Our chi-squared value was 0.2170. 0.2170. That's our chi-squared. Is it greater than 3.84? No, it's not. So what this means is we get to accept the null hypothesis. Therefore, gender and regular exercise are independent of each other. It doesn't matter what gender you are if you have regular exercise or not.